inclusive design project is Reimagining Wayfinding at UMD. Our project aims to develop a comprehensive and indoor and outdoor navigation app for University of Maryland campus. The primary goal is to provide all users, including those with disabilities, with a user-friendly tool that simplifies and enhances their navigational experience within campus. Our process was very simple. We first decided to understand the existing UMD app to see how indoor and outdoor navigational maps were displayed. From this, we realized that users can only zoom in and zoom out the map and the photos of existing maps of the building. With this, we recognized the importance of conducting thorough research on our target users. This preliminary research was crucial in helping us understand the needs and preferences of potential user base. One key insight we gained early was that the project topic we had chosen had a potential to greatly benefit a wide range of users through accessibility and inclusivity features. We researched about people with different disabilities and what challenges they faced in their daily lives when using digital tools. With this understanding in mind, we created personas that represented different disabilities. Developing these personas allowed us to delve deeper into unique needs, challenges, and goals of individuals with various disabilities, providing us with a solid foundation of a project. To gain deeper insights, we decided to take the next step and conduct user interviews. We were fortunate to identify and engage with 3 willing participants. Our first participant had motor disabilities and relied on crutches for mobility. This interview helped us gain insights into challenges faced by individuals with physical impairments when navigating from one point to another on campus. The second participant had ADHD, a condition that can be represented unique challenges in university setting. This allowed us to understand how individuals with ADHD experience and cope with the demands of university life when traveling. Our third participant experienced anxiety. This interview shed on the emotional and psychological aspects of commuting within the university and helped us better understand the needs of individuals dealing with anxiety. Based on all the information gathered, we decided to create use cases for people who use wheelchair for navigation, an international freshman, and some features for colorblindness.
For this use case, we will consider a user named Jack who uses a motorized wheelchair to navigate his way around campus. With construction around campus, Jack often finds it difficult to know which road is still accessible and if his wheelchair can go through a certain route. After a meeting at Hornbeck, Jack wants to reach Edward St. John's for a class. Jack opens the UMD app to check his schedule. He then opens the campus map to check directions from his current building, Hornbeck, to Edward St. John's. The app prompts him to choose a mode of navigation. He chooses the wheelchair option and proceeds to the main campus app. Jack's current location is highlighted. Since he chooses the wheelchair option as his mode of navigation, the map also marks all slopes and stairs for him. By tapping on his current location, he can see which entrance of the building he is at. Tapping on the slope icon lets him see the elevation of slopes, which lets him decide if his wheelchair can ascend the slope. The app allows users to either tap or search for buildings. He taps on the Hornbeck building, which takes him to a screen with all the building details. The screen includes pictures of how all entrances look along with their names. Their current location becomes the default picture. However, they can scroll through images and that becomes the default location. Jack adds Hornbeck North entrance as his start point. This action highlights the start point of his journey on the map. Next, he chooses to search for ESJ, his destination building. He chooses it from his recent locations. Tapping on a building name displays all accessible entrances. He chooses the one closest to his classroom. This action highlights the current location, the destination, the route, and any slopes and staircases he should be aware of. He clicks on Start to begin his journey. This takes him to a split screen with a live view of the route, directional arrows floating in augmented reality, and a flat view of the campus map. The app also provides safety warnings. when a user is about to cross roads. Jack, however, decides to exit his screen and decides to view the number of steps it would take him to reach his destination. He proceeds to navigation in this view until he reaches his destination. The steps marked complete turn gray, and the app provides constant updates on any obstacles in on the way. He exits his navigation once he reaches.
In addition to these, we also implemented two more features. Users with color blindness now have the option to select a color palette that suits their needs by modifying the map's user interface. Users can choose between red blind, green blind, and blue blind color palettes. By choosing the red blind color palette, the map changes its interface by choosing the colors from the color palette. Users can also now choose layers and switch between different options provided by the university's app. It includes dining services, building amenities, campus transportation, etc. By clicking on dining halls, users can see the dining halls which are nearest to them and can access the route through that. Another feature was individuals who use wheelchairs can now customize their routes based on the steepness, curb height, and slopes, enabling them to access the routes that align with their specific preferences and needs.
For our next use case, we will consider a student named Sophie, an international freshman who's often navigating her way around the campus. Sophie is currently running late for a meeting with an administrator whose office is located in the Hornbeck Library. Despite having visited the library a few times before, she finds herself lost most of the times. Sophie decides to use the UMD app to reach the exact office without being late. On the app's homepage, she taps on Navigation in the bottom navigation bar. This action takes her to a screen that provides options, allowing her to choose between the campus map, indoor maps, saved places, and shuttle services. She taps on indoor maps as she is already inside the building. This screen enables her to search for or choose from recently viewed buildings. Sophie taps on Map View as she intends to navigate through the building she is currently in. The indoor floor layout of the library loads, giving Sophie the flexibility to change the current floor in case the GPS malfunctions. Additionally, on the screen, you can observe icons for accessibility and layers. While we've already discussed accessibility, when clicking on layers on an indoor map, users can toggle various features on and off based on their needs, ranging from academic spaces to emergency services and building amenities. Sophie types in the room number given to her in the search bar. The map zooms in to highlight the location, and then she proceeds to click on directions. She's given an overview of the time that it will take, along with the distance. She wants it to be quick and easy and decides to tap on Live View. The screen transitions to the live view mode, utilizing the device's camera to overlay augmented reality directions onto the real-world environment. Sophie sees animated colored arrows floating in her camera view, guiding her along the path through the library. As she walks and finishes each step, any wrong turn is detected, and it usually uses visual indicators like these to show which side you need to turn to correct your path. Once close to her destination, the distinctive red marker appears, serving as a clear indicator that she is in close proximity to her location. On reaching her destination, the app provides clear feedback that she has arrived and is able to exit the navigation.